In section 3.3, we are looking at zeros of polynomial functions using the remainder theorem, which states that if a polynomial f of x is divided by x minus c, then the remainder is equal to f of c. So this is a way that we can use synthetic division to evaluate polynomials for given values of c. Also, the factor theorem states that a polynomial f of x has a factor x minus c if and only if f of c is equal to 0. That means when you're using synthetic division and end up with a remainder of 0, that means you have found a factor of that polynomial. Let's take a look at example 1 on page 8 of the notes. Using synthetic division, determine if the following are factors of the given polynomial. Is x minus 3 a factor of x squared minus 2x minus 3? Since we want to know if x minus 3 is a factor, we are going to put a positive 3 in the box set up for synthetic division, and then using the coefficients of x squared minus 2x minus 3. Using the steps of synthetic division, bringing down the first term, first coefficient, and then multiplying by the number in the box. 1 times 3 is 3, adding negative 2 and 3 to get 1, and 1 times 3 is 3. Add those to get 0. So what that means, if we have a remainder of 0, that means that x minus 3 is a factor. So x minus 3 is a factor. Yes, it is. Okay. And this also corresponds to a point that's on the graph of our point on the graph of y equals x squared minus 2x minus 3. So the point that corresponds to that is 3, 0. When you plug 3 into this polynomial, into x, the y value is 0. We can also write that as f of x is equal to x squared minus 2x minus 3 using function notation. Let's look at the second part. Is x minus 1 a factor? Using synthetic division, our setup involves putting a 1 in the box because x minus 1, we want to know if x minus 1 is a factor. And then writing the same coefficients, 1, negative 2, and negative 3. Using the method of synthetic division, bringing down the leading coefficient and multiplying by the number in the box, adding the numbers above the line, and multiplying. What we're looking for here is the remainder 0? If the remainder of 0, that means we have found a factor of that polynomial. Since the remainder is not 0, we could say no, x minus 1 is not a factor. But it does correspond. This gives us some information about the graph of f of x equals x squared minus 2x minus 3, which would be the point 1, negative 4. That is going to correspond to the graph of that function. For the next example, let's look to see if x plus 2 is a factor. If x plus 2 is a factor, we want to put a negative 2 in the box set up for synthetic division using the coefficients 1, negative 2, and negative 3. Bringing down the first coefficient and multiplying, adding and multiplying and adding, we see that that remainder, that last term is 5. That means the remainder is 5. If the remainder is 0, we know we have found a factor. So the answer here is no, x plus 2 is not a factor. But there is a point that corresponds to the graph, which is -2, 5. Finally, is x plus 1 a factor? Using your setup for synthetic division, we are going to put a -1 in the box using the same coefficients, 1, -2, -3. We multiply and add, multiply and add. We do get a remainder of 0. So yes, x plus 1 is a factor. And there is a point that corresponds to the graph, where x is -1, y is equal to 0. This is going to give us a new tool or another tool for factoring polynomials. And this could be very helpful as we proceed through the chapter and looking at how to factor polynomials. So now let's look at the graph of the function f of x equals x squared minus 2x minus 3. The previous questions were all we were asked to determine if any of those were factors. Well, it just so happens that we can factor our x squared minus 2x minus 3 using the factoring techniques that we learned in our previous math classes. It's a trinomial. It's an x to the second power. That means it could have 2 factors. It also means a graph could go in 2 directions, 1, 2, and it also means that the graph can cross through the x-axis up to 2 times. So if we factor using our previous techniques, we look at the factors of -3 that will add up to -2, and we could see that the factors are x minus 3 and x plus 1. So when we're asked on this page, is each of these a factor? Since it is an x to the second degree polynomial, there can only be 2 factors. And we did find 2 of those factors. We found that x minus 3 was a factor and x plus 1 was a factor. And in both of those cases, the remainder was 0. Now let's take a look at these points and how they relate to the graph of the function f of x equals x squared minus 2x minus 3. Here I have graphed the function using GeoGebra. You can use a graphing calculator. You can also sketch it by hand. And what synthetic division does is it helps us find points on the graph. So when we did, for example, when we plugged in -1 in the box for synthetic division, we got a 0 out. So that corresponds to this point right here, -1, 0. Plugging in a -1 in synthetic division, we get a remainder of 0, and that corresponds to the one of the x-intercepts. When we did synthetic division with a 3 in the box, we ended up with a remainder of 0. When we did synthetic division with a 1 in the box, we ended up with a remainder of -4. So it was not a factor, and it corresponds to the point on the graph where x is 1 and y is -4. This point, when we put a -2 in the box, our remainder was 5. That is the value. So there is a lot of connections between a quadratic function or a polynomial function. In this case, it's a second degree polynomial. It could have 2 factors, 1, 2 factors. It could cross through the x-axis 1, 2 times. And synthetic division is a way that we can use to find factors of not just second degree polynomials, but third degree polynomials or fourth degree polynomials and so on.